Hello everyone, my name is Gupta and today I will be presenting my work for the CNCF Antrea project under the LFX Mentorship Program Term 2 2025. My focus on enhancing packet capture with IPv6 support and flexible filters. I was mentored by Antrea and Hang Yan. Thank you for your support and guidance, mentors. In this talk, I will cover the problems we addressed, the improvements we made, and examples of how these changes enhance debugging and observability in Kubernetes networking. So these are my three contributions: support arbitrary source or destination, capture packets at the destination pod, and the last IPv6 support for the packet capture. For each of the topics, we will cover schema and API changes, BPF for controller logic updates, and the usage example. So let's move on support arbitrary source or destination. So earlier, packet capture required both source and destination pods to be defined. This was restrictive. We couldn't capture traffic for just a single endpoint. So we removed this limitation and now the user can specify source or destination or else both. And it helps to capture all traffic from or to a single pod, acting as a ingress or egress in nature. These validations make sure that at least one of source pod or destination pod must be specified by the user, and for a source or destination, at most one of pod or IP may be set. BPF program update. Now it adapts based on the availability of the source IP and or destination IP. It helps us for the calculation of instruction size and escape false variable. This is the manifest file example. Earlier we have to specify both source and destination. Now we can specify only source or destination as well, but make sure it must be a pod. nctl binary command example. Earlier we have to specify source and destination both flags, but now we can also specify only source or destination pod flags. So earlier, source pod destination pod.pkbng was the expected file, but due to the updated single endpoint captures, now we get to see source pod.pkbng or destination pod.pkbng files as well. Let's move on capture package as a destination pod. So previously, packet capture defaulted to the source if source port is available, otherwise to the destination. Operators had no control over where the capture was performed. So we added a new field, capture point, having enum as source or destination. Now user can specify where to perform the capture, either source or destination as a point. So if the user has specified capture point, and if it is source, then the source port must be set when capture point is source, vice versa for the destination. Added capture point field in the packet capture spec to specify where to perform the capture. So as I discussed in the problem, the same logic is written in the earlier code snippet. So currently, if the user has not specified the capture point, so based on the availability of the pod, we assign the capture point source or destination for the user. And based on the capture point, the, the packet capture get occur at that location. This is the manifest file example. We have specified both source and destination ports and capture point as destination. So the packet capture will get occur at the destination point. nctl binary command example. So we have added a -p flag, which is a capture point. Now user can specify where the packet capture should be performed, source or destination. So if a user forgets to put -p flag, it automatically defaults capture point as source because the source pod is specified. And if both source and destination pods are specified, then -p destination can help us to perform the capture at the destination location. Let's move on IPv6 support. So previously, packet capture was only supporting IPv4, and as dual stack clusters are becoming common nowadays, so IPv6 support was needed. So we have extended the IPv4 family support by adding IPv6 and introducing a schema extension for the new ICMPv6 message matcher API. And ICMPv6 transport header is analog to the ICMP, which uses IPv4. And further, ICMPv6 support with message type filtering and ensured validation to avoid conflicts. And these validations make sure that at least one of the protocols must be specified. So we have added ICMPv6 header to the transport header struct, and ICMPv6 message type defines a custom type for representing ICMPv6 messages types as strings, and along with this type, there are a set of constants as a numeric value. So the ICMPv6 message matcher containing the field type and code with type being integer or a string type value and code being the numeric value, and ICMPv6 header containing the messages array which can hold multiple filterings value. So this is equivalent to ICMP6, ICMPv6 type equal to type, and ICMPv6 code equal to code, filters in TCP dump. So for the BPF program update, we implemented passing for IPv6 header with a fixed header offsets, the feature of the IPv6, where we can easily get the fields like source destination addresses, ports, and the ICMPv6 codes. nctl binary command example. Now the user can specify the IP version, IPv6, following by the protocol and the further fields. ICMP being uses IPv4 and ICMPv6 uses IPv6. TCP UDP being used like both IPv4 and IPv6. So the ICMPv6 having ICMPv6 underscore type field and type ICMPv6 underscore code for the ICMPv6 protocols, which is just an analog to the ICMP. As you can see, the user can specify that dash f IPv6, ICMPv6, ICMPv6 underscore type, either it can be numeric value or the string value, and the IPv4 being be the default value. So this is the manifest file example for a single type filtering, destination unreachable, and either it can be numeric or the string value with the additional optional code port unreachable. This is just an analog of the manifest file example to achieve the same goal. So this is the another manifest file example having two types of filtering. They both will be in OR condition, equal request, equal reply. Either it can be numeric value or the string value. Due to the limitation of the entity binary, we can just specify the single filtering, equal request or equal reply. Now I will show you the demonstration. So I'm having two nodes running and two Antrea agents on the two different nodes, and Antrea toolbox being the source pod on one of the node, and Antrea toolbox, ICMPv6 and TCP acting as a destination pods on the different node. I have also extracted the IP values for the each of the pods. I'll show you the CR for the first case. So I have specified only source. This is a source only case, and IP family being set to the IPv6, protocol as TCP, and direction as both, which will help us for capturing ingress and egress traffic of the pod. Let's capture the packet. So we have captured the packets. Let's copy from the pod. Let's check the packet file. So we got the packets having source and destination, IPv6 and TCP protocol. As we have specified source pod, so there can be many destination in the packets. Let's see the second case. I will show you the CR for the second case. So over here, we have specified both destination and source ports, direction being set to both, and capture point as a destination. So packet capture will occur at the Antrea agent pod running on the same node as the destination pod, Antrea toolbox ICMPv6, and the .pkmg file will be stored there, which I have shown you in the first terminal. IP family as IPv6, ICMPv6 protocol, and messages as echo request or echo reply. Let's run the command. So we have captured the packets. Let's see the packet file. So we have got the packets file having both IPv6 source and destination, ICMPv6 protocol, and echo request or echo reply as ICMPv6 messages. Let's check out the anti-CTL binary. So over here, I just specified source pod with 5 number of packets and the direction as a both and flow field as a IPv6, TCP and TCP destination port as 80. So we got the file. Let's check out. So we got the package which is same condition as the CR. Let's check another case. So over here, source and destination, both ports are specified with 10 number of packets and direction as both and the capture point as a destination with further flow field as IPv6 and ICMPv6 and type value as echo. So it has captured the packets. So as you can see, echo ping request and source and destination having IPv6 values and ICMPv6 protocol. So this was all from my side. Sorry I could not attend the entire community meeting due to academic commitments in the morning. Thank you for watching the recording and thank you mentors and the entire community for believing in me and giving me this opportunity. I will look forward to contributing more to the entire project. For any queries, please feel free to reach out to me on Slack. My username is Asgarudakun and the real name is Harsh Gupta. Thank you.